Hello guys, so today I'll be explaining the physics quiz of term 1, week 5. So let's start. What are some far-fetched sources of energy? We have 4 types of far-fetched sources of energy. The first type is microbes. What do the microbes do? The microbes, they have CO2. They will use sunlight energy to convert the CO2 into either natural gas or hydrogen gas. So this is for the microbes. Then, what do we have? We have giant solar collectors. What do these giant solar collectors do? They take sunlight energy, they convert it to electrical, okay? And then the electrical will be converted into microwaves, not the microwaves in the kitchen, no. They mean the microwaves like the waves, like the gamma rays, the ultraviolet waves, the X-ray waves, etc., like this. And then the microwaves will be transmitted to underground antenna and they will be collected. That was number 2. Now number 3, we have nuclear fission. So what about nuclear fission? Nuclear fission is called far-fetched because it can change the amount of energy. So 1 kg of fossil fuels, if we do nuclear fission, what will happen? It will give us the same amount of energy as, imagine, 10 million kg of the same fossil fuels. So imagine, with nuclear fission, 1 kg of fossil fuel is equal to the same energy released by 10 million kg of fossil fuel. So this is very, very important. Now the final thing we have is matter-antimatter. So what about matter and antimatter? They are two opposite things. For example, we have a proton, the charge is +1, and we have an antiproton, the charge is -1. It's not an electron, it's an antiproton. So when the proton and the antiproton meet, what happens? They destroy each other. Okay, and when they destroy each other, they release huge amount of energy. So this was for the far-fetched sources of energy. So based on what we just said, we can say that microbes, giant solar collectors, and nuclear fission are far-fetched sources of energy. Now, two bodies, P and Q, form a system. After some interactions, Q has lost 80 joules and P has gained 60 joules. Now, this is something really important to remember. Lost is equal to minus gain, and gained is equal to minus lost. Now, keep this in mind while we solve. So Q has lost 80 joules. If we keep it in mind, we know lost is minus gain. So if we're talking about how much Q gained, okay, we know that gained for Q is gonna be the same value of joules, just we're gonna change the sign. So again, lost is equal to minus gain. They told us he lost 80 joules. So if we want to know how much joules he gained, we're gonna take gained, okay, of Q is gonna be the same number, but only a different sign. So lost and gained are opposites. This is basically the relation. Lost and gained are opposites. Now, let's take this one. P has gained 60 joules. We need to find how much P has lost. We said that gained and lost are opposites. So if P has gained 60 joules, then that means P will lose the same value, which is 60 joules, but we're only going to change the sign. So again, gained equals minus lost. We have that P has gained 60 joules. We need to find how much that P lost. So how much did P lose? It's the same value, the same number, 60, but only the sign changed. So for example, if they told you W gains minus 20 joules, how much did W lose? We said if it gains, we know that gained equals minus lost. So minus lost, we're gonna find out how much W lost. Okay, it's gonna be the same value, 20 joules. Actually, minus 20 joules is gonna be the same value, minus 20 joules, but we're gonna multiply it by a minus, or we're gonna put a minus next to it. So minus times minus becomes plus. So that means W lost 20 joules. So it's very, very fun to play the game like this. Lost equals minus gained, and gained equals minus lost. They are the opposite of each other. Okay? So, which statements are true? Body Q has gained minus 80 joules. We said it lost 80 joules, so how much did Q gain? We're going to have the same value, but we're only going to put a minus. So minus 80 joules. So it did gain minus 80 joules. Now the system gained 140 joules. Let's see. Here, P, we don't need to change it. P, it gained how much? 60 joules. And we know that Q has lost 80 joules, so that means Q will then gain minus 80 joules. And to find the total gain, so the total gain is equal to how much the system gained in Q, so gain in Q, plus the system gained in P. So total gain is equal to how much did we gain in Q? Minus 80. Plus how much did we gain in P? 60. So how much did the total system gain? Minus 20. So that means it did not gain 140 joules, it gained minus 20. Or in other terms, we can say that the system has lost 20 joules because we said lost is equal to minus gain. Okay? If we're looking for how much was lost, okay, and we have the total gain, we're gonna take lost of the system S, okay? It's the same value, minus 20, but we're gonna put a minus. So minus times minus 20, it will become plus 20. So it will lose then 20 joules. So the system has lost 20 joules. Now, is the system isolated? No. How do we know? If a system is isolated, it will neither lose nor gain. So it should have either gained 0 or lost 0 if it's an isolated system. Why? Because they're exchanging energy only between themselves, and so there will be no energy loss and no energy gain. So isolated system, it will neither lose nor gain, or it will lose 0 and gain 0. So again, we said the system has lost 20 joules. We know that lost is equal to minus gain. Okay, minus gained. So if he lost 20 joules, we know that he will then gain the same value. It will stay 20 joules, but we're only going to put a minus. So that means he gained what? He gained minus 20 joules. So again, please remember, in the isolated system, no lost, no gain. No means 0, so 0 lost, 0 gain. Also, remember that gain equals minus lost, and lost equals minus gain. So this is it for number 2. Number 3. Two bodies, P and Q, form an isolated system. What does it mean, isolated system? That means gain equals lost, okay? Or it doesn't necessarily, like what I explained before was just a brief explanation, like it neither loses nor gains. But in reality, gained, the total gained, okay, will be 0, and the total lost will be 0. So the gain will be equal to the lost, which is equal to 0. Again, in an isolated system, the gain is equal to the lost, which is 0. Now, let's take it like this. If gain equals minus lost and lost equals minus gain, let's play it like this. The energy gained by P, okay, plus the energy gained by Q is equal to 0. Remember, we said that the total gained is equal to 0 and the total lost is equal to 0. So if the energy gained by P plus the energy gained by Q, this will form what? The total gain. And we know that the total gain is equal to 0. This is only the case in the isolated system. Okay? Now again, we remember that energy gained equals minus lost. Okay? And energy lost equals minus gained. This is what? A general rule. Okay? But in the isolated system, we said in the isolated system, the total gain is equal to 0 and the total loss is equal to 0. What does it mean? That means the energy gained by P plus the energy gained by Q is 0. So EP plus EQ equals to 0. If you move EQ to the other side, then EP is equal to minus EQ. That means what? That means energy of P is equal to, we said, minus energy of Q. And this is what? The gained. So I'm going to put here a small g, indicating that it is gained. Again, I will repeat because I need this concept to be very understood. Only in the isolated system, the total gained equals 0 and the total lost equals 0. Okay, so we know that energy gained by P plus energy gained by Q is equal to 0. So energy gained by P plus energy gained by Q is equal to 0. If we move energy gained by Q to the other side, we will then have energy gained by P is equal to minus energy gained by Q. Okay? Now, if you remember, we said gained equals minus lost, and lost equals minus gained. If you look over here, we have minus gained. And we said that lost is equal to minus gained. What does this mean? This means that in the isolated system, the energy gained by P is equal to the energy lost by Q. Okay? So it's more of math than physics in this case. So I will recap really quickly because this is very tricky. I need it to be really explained really well. We know that gained is equal to minus lost and lost is equal to minus gained. Keep this in mind. Always keep this in mind. We know that in an isolated system, the total gain is equal to 0 and the total loss is equal to 0. So the energy gained by P plus the energy gained by Q is equal to 0. Okay? So energy gained by P plus the energy gained by Q is equal to 0. That means the energy gained by P is equal to, when you move energy of Q, so the energy of P gained is equal to minus the energy of Q gained. And we said that lost is equal to minus gained. Here we have minus gained. So that means you can substitute the minus gained into lost. So that means the energy gained by P is equal to the energy lost by Q. So we said energy gained by body P is not equal to energy gained by body Q. It's equal to minus energy gained by body Q. We also know that the total energy lost is equal to 0. So the total lost is equal to 0. Okay? And okay. And we said that we explained over here. We said that the energy gained, the energy gained by P, we said we denoted that it's equal to the minus of energy gained by Q. So if energy gained by P, it's not equal to minus energy lost by body Q. In fact, the energy gained by P is equal to the energy lost by Q. However, we know that if it is the same body, okay, then the energy gained by body P is equal to the minus of the energy lost by body Q. Why? Because lost is equal to minus gain, and gained is equal to minus lost. Okay, so again, I will repeat it. I'm gonna repeat it again. I know it's gonna be a long video, but I need this concept to stick very well. It needs to be very, very important. Okay, so we have an isolated system. In an isolated system, we know what? We know that the total gained is equal to 0 and the total lost is equal to 0. Keep this in mind. We know also aside that gain equals minus lost and lost equals minus gain. Okay? So the total gain means the total energy gain means the energy gained by P plus the energy gained by Q, because we have only two bodies in the system. Okay, we know that the total gained is equal to 0. So energy gained by P plus energy gained by Q is equal to 0. What happens if we move energy gained by Q to the other side? It becomes energy gained by P is equal to minus energy gained by Q. Look what we have here. Minus energy gained by Q. We know that minus gain is equal to lost. So very simply, anytime we have minus gain, we can put instead of minus gain, lost. So the energy gained by P is equal to the energy lost by Q. So what we can understand from this rule is that if they are different bodies, then the energy gained from one is equal to energy lost from another. But if they are the same body, then the energy gained is equal to minus the energy lost. So again, if they are different bodies, this means different bodies, energy gained equals energy lost. Okay, let me write it up, it's clearer. So if they are different bodies, okay, energy gained equals energy lost. However, if they are the same, this means the same, I will write same here, same bodies, then the energy gained is equal to minus of the energy lost, okay? And the energy lost is equal to minus of the energy gained. So please, if you need me to re-explain this, I will more than gladly, because it's a very important concept, okay? Now, question number 4. For each example, state whether the interaction described occurs with or without energy transfer. How do we know if it occurs with energy transfer? It has to be moving. Okay? It has to be moving in a direction. Okay? I will explain further here. But remember, if there is energy transfer, it should be moving in a direction. And if it's without energy transfer, it's not moving, or it's uniform. Uniformly moving. So, in this example over here, we have a book is resting on a table. If the book is resting on the table, it's not moving. Directly, anything that's not moving has no energy transfer. A bucket is lifted, this is motion, it's moving. Upward, this is a direction. So it has a motion and it has a direction. So this is energy transferred. Now, a rock travels uniformly. First of all, it's moving through open space. Okay? This is a direction. Here is why I wanted to explain. It is moving, but it's uniformly. This is very important. If it is moving uniformly, then we have no energy transfer. Okay? So, a rock travels uniformly, there's no energy transfer. Now, a ball is in free fall. What is a free fall? There is no air resistance. That means the ball is just falling. Okay? So definitely there is an energy transfer because it's being pulled by the earth towards the earth. It's being pulled towards the earth, and there's nothing to stop it, nothing to balance the forces, which was the air resistance. So that means a ball is in a free fall, it has an energy transfer. So remember, if it's not moving, it is no energy transfer. If it's moving uniformly, there is no energy transfer. But if it's moving and it has a direction and it's not uniform, then there is energy transfer. Question number 5. Same thing. A book is resting on a table. If it's resting, we have no energy transfer. Here, a bucket is lifted upward at a constant speed. Now look, the bucket is lifted. The bucket is lifted upward, but it's not uniform. So we have a motion and we have a direction, and it's not uniform, so there is energy transferred. Then again, we have a rock travels uniformly through open space. It is traveling uniformly, so there is no transfer. And then finally, a ball is in a free fall, so then there is energy transfer. Question number 6. A person is pulling a box along a rough floor using a rope parallel to the ground. The tension in the rope is 25 newtons. and the box moves through 2 meters at a constant speed. So they need the work is force times distance by the frictional forces. What are frictional forces? They are resistive. So if it is a resistive force, that means the force is gonna become negative. We have 2 types of forces. We have motive forces and we have resistive forces. What do motive forces do? They move same direction. Okay? Resistive forces move the opposite direction. Now, what happens in the motive force? They get what? Plus force. What happens in the resistive force? They get negative force. So, motive, same direction, plus force. Resistive, opposite direction, negative force. So, we are given the force, which is 25 newtons. This is our F. And we are given the distance, which is 2 meters. We said frictional forces are resistive. So what does it mean? That means our force has to be negative. So if F is 25, then minus F is minus 25. That means the work done by the frictional forces becomes minus F times D, which is minus 25 times 2, which is minus, here's the minus, let me use a different color, minus 50 joules. So again, frictional forces are resistive, and anytime we have resistive forces, what do? We do minus force times distance. Our force is 25 and our distance is 2, so it becomes minus 25 times 2, which is then minus 50 joules. So our answer here is minus 50 joules. Question number 7. Match each device with its chain of energy transformation. We have a solar cell. What does the solar cell do? It changes the light into electricity. Light can be electricity. Okay, light can be radiant energy. So definitely, solar cell will transform radiant into electrical. What does a water dam do? It stores the water, and the water has what when it's stored? It's above the ground level, so it has a potential energy. And then what happens? Then it will fall down, and this falling is kinetic energy, and the falling of the water will then lead to electric energy. So again, water dam has potential energy because it's high. Then it will fall down, so this is the kinetic, this is potential, this is kinetic, okay? And then it will be transformed into electric. So that means the water dam is potential kinetic energy. Wind turbine, what happens in a wind turbine? It's moving. This is a turbine, for example. The blades will then move, for example, in this direction, and it will generate electricity, and the energy of motion is kinetic energy. So wind turbine, kinetic to electric. Question number 8. State whether each of the following types of power plants run on a renewable or non-renewable energy source. So, we know, let me just write the renewable types of energy sources. First of all, we have wind turbines. Or no, let me not number them. Renewable energy, RE, we have wind turbines. Then we have hydroelectric energy. Then we have tides and waves. Then we have the ocean thermal energy conversion, OTEC. Then we have geothermal. Then we have solar energy. Then we have biomass. And then we have biofuel. So these are our renewable energy. Wind turbines is wind energy. The wind will turn the turbines and it will change kinetic energy into electric energy. Hydroelectric, it is what? It is the water. It's stored in a dam. It has gravitational potential energy. Then it will fall. It has kinetic energy. Then the kinetic energy will turn the generators, which is kinetic energy again. And then it will be what? It will be electric energy. Tides and waves do similar thing to hydroelectric, but they're only moving. They don't have potential energy. We have the OTEC the ocean thermal energy, there is a temperature difference between the surface and several hundred meters below the ocean. So what do? They do a process called OTEC, okay? And they will make energy out of this. So they're changing thermal energy into kinetic, into electric. Geothermal energy is the heat from within the earth. What happens is that magma heats the rocks, and then the rocks heat the underground water. And then the underground water will make steam, and the steam will move, which causes kinetic energy, and the generator will move, which will cause electricity. Then solar energy is by its name, from the sun. Biomass is the utilization of energy. Basically, biomass is from organic materials that were once alive, okay? They were once alive materials. For example, it could be a dead plant or dead waste from the animal. We don't know what, but biomass, yeah. They will make it into energy. And biofuel, it's mainly corn. What is it? It's mainly corn and grasses. They are fermented. They produce alcohol that will produce the fuel. So these are our 1, 2, 3, 4, 5, 6, 7, and 8 types of renewable energy. Oh my goodness, I dropped my pen. Okay, so we said natural gas is non-renewable. It's not one of our renewable sources. Then we have hydroelectric is renewable, wind is renewable, and tidal or tide is renewable. So this is for question 8. Question 9. In what way are nuclear power plants reliable? How are nuclear power plants reliable? They will respond quickly to any fluctuation in electricity demand. Now, something quick about a nuclear power plant. They produce 1/6 of the world's electricity. Then there's nuclear fission, which we explained multiple times before. I hope you know, because I'm not going to explain it now. The advantages of nuclear power plants are that they are reliable because they respond quickly to any fluctuation in electricity demand. Disadvantages are the nuclear waste, because they must be buried underground by lead. We have the psychological bias, and we have that it's very expensive. Question number 10. Okay, what is the power output of an OTEC plant? Remember only that the OTEC plant is 100... one second, let me check. It is 100 megawatts to 160 megawatts. Please remember this. So OTEC is between 100 and 160 megawatts. Question 11. The heat energy from the earth is called geothermal energy. Very logical. Earth is geo, heat is thermal. So put first the earth, then the heat. So it's going to become geothermal energy. So very logical. Earth is geo, heat is thermal. Together, geothermal energy. So this is geothermal energy. Question number 12. What are some advantages of solar energy? Okay, just remember, solar energy, it's free. It's free in the sense that it doesn't cause any harm to the earth. It is clean. It doesn't harm the earth again, and it's reliable. Okay, so sorry, it's not reliable. My bad. It's not reliable. It's renewable. So solar energy is not reliable. It's only clean, free, and renewable. So clean, free, and renewable. Question number 13. Using the figure below shows blah blah blah. Okay, this is a very logical question. They're telling us the energy lost by the football between positions A and B is, very simply, at A it was 100 joules, at B it became 75 joules. So from 100 to 75, what happens? It decreases by 25 joules. So they're telling us the amount of energy lost by the football is 25 joules. Okay, if they asked us the energy gained by the football, what do? We know that gained is equal to minus lost. So if he lost, and lost is equal to minus gain. So if he lost 25, lost equal 25, then gain is gonna be the same value, but only put a minus. So G is equal to minus 25 joules. He will gain minus 25 joules. But here they're asking how much he lost. He lost 25 joules. So 25 joules. Number 14, this is very important. A block of wood is sliding. Let me explain this one by itself. Force times distance is work. W is equal to force times distance. Wait, it is a force. So force is equal to weight, and weight is equal to the mass times the gravitational force. So that means you can replace the force by mass times gravitational force. And then you're going to keep the distance. The distance is equal to the height. Distance is equal to the height, which is 6 meters. So now, from this equation, we made a new equation, which is m times g times h. I prefer to use h and not d, because d will keep it for f times d. Okay? So again, let's draw it again. I'm going to take my time on these. I'm sorry if it's a long video, but I really need to focus on these. So this was 30, this is 90, and this is 60. Here I did a mistake. Okay, minus. Amanda, cut all of that out. Question number 14. A block of wood is sliding down a rough inclined plane. So we have a rough inclined plane. Okay, making an angle of 30 degrees with the horizontal. So this over here is 30 degrees. And we know that this is 90 degrees, so this leaves us with this angle over here being 60. So now we have a semi-equilateral triangle. I need you guys to remember your math, because right now physics isn't physics anymore, it's being math, okay? You have to remember your math from previously, and it will help you in your physics this week. So, the mass of the block is 2 kg. 2 kg is equal to the mass. The force of friction, friction is a resistive force. Acting on it is 3 newtons. The block moves along an inclined plane through 6 meters. So it's sliding down. It's going down like this, 6 meters. So this is our force. We have the hypotenuse. This is our triangle, sorry. We have our hypotenuse, which is 6 meters. If you remember from previous years, okay, you guys have to know your math, or else you're not gonna do well in this physics AMS. Okay, because I'm not gonna explain the math and the physics. If you remember from last year, if you had a semi-equilateral triangle, what was the rule? This is 30, this is 90, this is 60. The rule was that the hypotenuse is 2x, the 60 and 90 is x, and the 30 and 90 is x radical 3. Please guys, remember this, remember what you learned in math last year. So then, what can we do here? We can say if this is 6 meters, then the angle between, the side between 60 and 90 degrees is going to be 6 meters over 2, which is 3 meters. Now this is our distance or height, okay? Now I will tell you why we used or height. They're asking us the work done by the weight. Force is a weight, or weight is a force, for example. The weight is a type of force. So if you're doing force times distance, and they're asking for the work done by the weight is a force. And we know that the rule for the weight from previous years is the mass times the gravitational force. Okay? So the gravitational force here is 10 meters per second squared. And the weight is 2. So that means our weight is equal to mass times g, which is equal to 2 times 10, which is 20. Now we have the value of our weight, which is our force, which is 20 newtons. Now the distance or the height, okay, it was what? 3 meters. We found it to be 3 meters. So the work done by the weight of the block is 60 joules. Now there's something important, okay? Anytime you see the work done by normal reaction, remember that the work done by normal is always equal to 0. So that means the work done by the normal reaction on the block is 0 joules. So again, I will repeat this question. I know it's taking such a long time and I apologize for this, but I need this to be a really well understood concept, okay? So we have a rough inclined surface, okay? We have this is 30 degrees, this is 90 degrees, and this is 60 degrees. Okay? We know that the mass is 2 kg, and the g is 10 meters per second squared. We know that it was going down on the inclined surface by 6 meters. Using our math from last year, we can deduce this height, which is 3 meters. Okay? So, we have now our height or our distance. we know that the rule for work is equal to F times D. But here they're asking for the work done by the weight. So what about the weight? Weight, it is a force. And weight, it's equal to M times G. Okay, so that means what? You can replace the force by M times G because it's the weight. And we said you can either put the distance or you can put M times G times H. For us, what the teachers told us to memorize was M times G times H. Okay? So we have our height, which was 3 meters. We have our G, which is 10. And we have our mass, which is 2. So in total, the work done by weight is 2 times 10 times 3, which is 60 joules. So 60 joules. Now this is interesting. The work done by friction is, okay, we know that the force of friction, okay, again, let me draw the triangle. Okay, this was here 30, here 90, and here 60. We know that the force of friction is resistive. So the force acting on it is 3 newtons, but because friction is resistive, it's gonna be negative 3 newtons. And then they told us that the inclined plane through 6 meters, it was going down like this. So it was going down like this for 6 meters. So the friction, okay, it's gonna be, the work done by the friction is the force times the distance. But because friction is a resistive force, it's gonna be minus force times the distance. Now we're gonna take which distance? The distance of this one, because this is where the friction is acting. Okay? We're not talking about the weight or the gravity, which is like this, going downwards. No, we're talking about the friction, and the friction is exerted like this. Okay? So we're gonna do minus of the force. So the force is 3 newtons, so it becomes minus 3 times the distance, which is 6. So minus 3 times 6 becomes negative 18 joules. Again, I will repeat. We have a force of friction. Friction is resistive, so it's gonna be negative force times distance. We know that the force was 3 newtons, so it becomes negative 3 times the distance, which is like this. So times 6, it becomes negative 18 joules. Question number 15. I really apologize for the length of this video. A parcel of mass 2.5 is lowered vertically down by this. Okay. They need the work done by gravity. So the work done by gravity, or the weight, or the earth, they all have the same meaning, okay? Anytime you see these, they are the same meaning. They need the work done by gravity. In the last question, we deduced the rule by the work done by weight or gravity. It was M times G times H, okay? Now, we have to think of it like this. If the force of gravity is pulling it downward, okay? If you are lowering an object, okay? So then the force of gravity and the lowering of the object are in the same direction. And since they are in the same direction, that means they are motive or plus force. However, if you are lifting something, you're gonna be going in the opposite direction, which is up. So you're going what? Opposite direction. So it is resistive, okay? So it's gonna be minus force. Again, we have a surface and we have the gravitational force, or we will call it the weight, pulling it down. If you are lowering an object, it's going in the same direction, so it is motive, and motive means plus force. If you are lifting, you are going in the opposite direction, so it is resistive, and resistive means negative force. Okay, so the work done by the gravity, we deduced the rule for gravity, weight, and earth. It was M times G times H. Okay, so the mass is lowered, so that means it's not negative. We're gonna keep it all positive. The mass is 2.5 kg. It's gonna stay all positive, okay? Is lowered. Why is it all positive? Because it's lowered, okay? Through a distance or a height of 0.6 meters. They told us take the G as 10. So now what do we have? We have 2.5 times 10 times 0.6. So let's do it on the calculator. 2.5 times 10 times 0.6, we're gonna get 15. So 15 joules. So the work done by the gravity, which is downwards, is 15 joules. This work we said is motive, okay? Because it's the same direction. You see, it's being lowered vertically down, and we said if it's lowered, then it is motive. Now, tension. This is the string, and for example, this is what we are holding here. Now, what does the tension do? The tension will hold the bucket upwards, but what's the bucket doing? It's going downwards, yes? So if the original force is going upwards, okay, and the bucket is going, or like the parcel is going downwards, then they are in opposite directions, so they are resistive. So what does it mean? That means it's gonna be minus force, minus F. So we can say the work done by the tension is gonna be the force times the distance, but minus force because they are a resistive force, okay? So you can take it as the work done by the gravity, okay? You can take it very simply. The work done by the gravity is equal to minus the work done by the tension, okay? So we got that the work done by the gravity is 15 joules. So the work done by the tension is going to be the opposite because it's a resistive force. So it's going to be minus 15 joules. And this work we said is resistive because it's in the opposite direction. Now question number 16. Okay, a bob of a pendulum is swinging through the air. It makes one complete oscillation, moving from position 1 and then back to position 2 and then back to position 1. So the work done by the gravity on the pendulum over one complete oscillation. So look, the work done by the gravity, it started where it is and it ended up back where it is. So it basically didn't move, so the work done by the gravity is technically 0. Then the work done by the tension, the same thing. It started here, it ended up at the same place, okay? So over one complete oscillation, this is very important, the work done by the tension is 0 because it started in the same place and ended up in the same place. Now, the work done by the air resistance on the pendulum over one complete oscillation. You know that in the pendulum, over time, okay, it's moving constantly, yes? But then over time, it will slow down. Why? Because of the air resistance. The air resistance will slow it down. So, from its name, the air resistance is a resistive force. So, resistive force. Again, nothing changed in the pendulum. The initial position and the final position are the same. So the work done by the gravity is 0 over one complete oscillation. And the work done by the tension is also 0 because it's moving constantly. Same thing with the gravity. It's moving constantly. There's no change. So for the gravity and the tension, the work is 0. But the air resistance is the thing that will slow it down. Okay? So the complete oscillation of the work done by the air resistance is resistive because it will slow it down. I'm losing my voice. Okay, last question. Okay, a block of mass 1 kg. We have the mass, which is 1 kg, is pulled across a rough floor by a rope making an angle. So sorry, I had to cut off. Anyways, the block of the mass is 1 kg. We have the angle is 60 with the horizontal, and the tension in the rope is 5 newtons. Now there is another rule for work. We have the basic one, which is work is equal to force times distance. But in the more like general one, we have work is equal to force times distance times cosine angle made with horizontal. Okay? This is a more general rule. So the work done by the tension in the rope is, what's happening in the tension of the rope? It's going like this, yes? And we know that the work done in the tension, it moves through 8 meters, so this is our distance. Okay? Okay, so let me repeat it again. The work done by the tension. We don't have any mass, we don't have any gravitation and attraction for the tension. What do we have? We have force times distance. We have the force of the tension, which is 5 newtons. And we have that the block moves 8 meters. So this is the distance. Now the rope makes an angle of 60 degrees. Okay? What happens then? We are going to use the basic rule, which is W equals F times D, or we're going to use the more general rule, which is W equals F times D times cosine X, I will say. Okay? We have an angle, we have a force, and we have the distance, so we're going to use this one. So W is equal to the force, which is 5 newtons, times the distance, which is 8 meters, times the cosine of X, which is 60. So 5 times 8 is 40, and cosine of 60, just do 40 times cosine of 60 on the calculator. Sorry for the bad handwriting, by the way. 40 times cosine of 60, it's gonna be 20. And I dropped my calculator, but it's okay. So the work done by the tension, we said it was F times D times cosine X. Okay, so it was 5 times 8 times cosine 8, cosine 60, not cosine 8, and then we got 20 joules. So here the answer is 20. Remember, I said previously, anytime you see normal reaction, the work is 0. So here the answer is 0. Now the work done by friction on the block. How do we know the work done by friction? Quite simply, the work done by friction is negative F, because it's a resistive, negative F times D, and in this case we have an angle, so negative F times D times cosine angle X. So what was our force? Our force was 5 newtons. Okay, so negative 5 times the distance 8 times cosine the angle made with the x-axis or the horizontal is 60. So if you do it on your calculator, you are gonna get negative 20. So finally, our answer for this one is negative 20. So let's submit and check. I hope there are no mistakes. And gladly there are no mistakes. Now let me just write the rules. Okay. We have gain equals minus lost. Lost equals minus gain. In here, in the isolated system, okay, total lost equals 0, total gained equals 0. Then we have W equals force times distance. This is for the motive. Then W equals minus force times distance. This is for the resistive. Then we have W is equal to M times G times H. This is if we have weight. This is the work done by the weight or gravity or the earth. Okay. And then we have W equals F times D times cosine angle made with the horizontal. This is a general rule. So please, 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 guys, remember these. I'm so sorry this video was so long, and I'm so sorry I took so long to post it, but I hope it was good.